Now let's see the concept of minimal element and maximal element in a poset. Let me take an example and explain you. Let us say a set is there, capital A is containing two elements A, B. Then if I take power set of A and subset relation, okay, set inclusion relation, then it is a poset as well as a lattice. But then here we are applying these definitions just for poset, which means it is applicable both for poset as well as lattice. So if you try to draw the Hussey diagram, you are going to see phi here and you are going to see singleton sets A here and B here, and you are going to see AB here, right? Now if you see the element AB, it is not related to any other element. So what do I mean by related is, if it is not present in the ordered pair. Okay, what are all the ordered pairs here? How many ordered pairs you can see? You can nearly see, I think 4C2, 6 ordered pairs. Let's see this or no. Phi is subset of A, isn't it? Therefore you will see phi A as a relation. That is how you can get the ordered pairs. Now similarly phi B is an ordered pair which will be present in the relation. The reason is phi is subset of A, and similarly A, you will see that it is a subset of AB. Therefore A comma AB is an ordered pair which will be present in the relation, and similarly B is a subset, therefore B comma AB you will see, and similarly you will even find phi comma AB because phi is a subset of AB. I think that is all, right? And again along with this you will have reflexive relations as well. Okay, so what are the reflexive relations? Phi comma phi, A comma A, B comma B, AB comma AB. So anyway, just exclude those reflexive relations because they are not relations between two different elements. They are the relation between two same elements. Now apart from those reflexive, if I write all the relations, it is going to be this, right? If you see this, A comma B is not related to any other element. What do I mean by that? See, in this one, phi is related to A, that is how you should call it. Phi is related to B, phi is related to AB, A is related to AB, B is related to AB. Now if you see any of these ordered pairs, you will never find AB to be present in the first place of the ordered pair, which means you will never see like this A comma B comma something unless it is A comma B, right? Therefore what can you say about it? So if you find any such element which is not related to any other element, definitely it will be present in the topmost level, isn't it? If A comma B is related to some other element, then that particular element will be above it. But since it is not related to any other element, you can see A comma B in the topmost level. Then such an element is called as maximal element, right? Similarly, if you see phi, okay, so you can see that phi is present in the least level or the lowermost level, right? So one other way of saying it is no element is related to phi. See, phi is related to A, phi is related to B, phi is related to AB, but no other element is related to this, which means I can never have any ordered pair like this with phi here and something here unless it is phi. Other than phi here, I can never find any element. Therefore we can say that no element is related to phi. Then in that case it is called as minimal, right? So this is the minimal element and this is the maximal element. Now we have already seen something called as upper bound and lower bound. Now how is it different than minimal and maximal? Now I'll just give you one more example. Okay, so let's see the definition and then I'll get back to this. If in a poset an element is not related to any other element, then it is called maximal element. If in a poset, if no element is related to an element, then it is called minimal element. Fine. So that is the definition of maximal and minimal. Now according to the definition, if I take this poset, I got that it is the maximal element and it is the minimal element. Now what is the main difference between upper bound, lower bound and minimal element and maximal element is upper bound and lower bound are generally applicable for a lattice, right? Which means this element is going to be upper bound as well as lower bound, and this minimal and maximal is not only applicable for a lattice, it is even applicable for a poset, which means you can apply minimal and maximal element definition here and we can see that it is the maximal and it is minimal element, but then you can even apply minimal and maximal element to some other posets which are not lattices. So just for the sake of example, see this. Let us say I have 1, 2, 3, let's say 4, 6. Okay, now see this, it is a poset. So let me define the relation first. So let us assume that it is a set containing 1, 2, 3, 4, 6, 5 elements, and the relation is divides. This is a poset. Okay, this entire thing is a poset. Now in this poset, is this poset a lattice? Okay, before going to lattice, let's see what are the minimal elements and what are the maximal elements. Now what is the definition of a minimal element? If an element is there and no other element is related to it, then it is minimal element. Now if you see this, in this particular example, 1, right, no other element will divide 1 unless it is 1, therefore it is the minimal element. And what is the maximal element definition? If an element is not related to any other element. So in this particular poset, 4 does not divide any other element, and similarly 6 does not divide any other element. Therefore if you observe this, in this particular poset, the maximal elements is 4 and 6. There are 2 elements, right? And minimal elements is going to be only 1. Understood this? Okay, now let's take one more example. Let us say we have the set 2, 3, 4, 6 and 24. Sorry, 24. This is the set and divides is the relation. Now let's see what happens. We have 2, 3, 4, 6, right, and 24. So in this particular poset, the maximal element is going to be only 1, which is 24, but if you see the minimal elements, it is going to be 2 and 3, 2 elements, right? That is the difference. Now this is a lattice. In a lattice, the upper bound and the lower bound, if they exist, are going to be the maximal element and minimal element. Therefore in a lattice, the maximal element and minimal element are going to be unique, only 1. That is in a bounded lattice. But then if you see in a poset, so this is a poset which is not a lattice. Why do you think that it is not a lattice? Okay, so don't get confused. So go slow. Let's go slowly. Now this is I'm calling it as a poset and it is not a lattice. Why do you think that it is not a lattice? The reason is simple. If a poset has to be a lattice, every pair should have least upper bound and greatest lower bound. Now if you take 4 and 6, these two are not going to have least upper bound, right? No element is above them, therefore it fails to be a lattice. Okay, but it is just meet semi lattice. The reason is every 2 elements is going to have lower bound, but then not the upper bound. That is why this is not a lattice. So In case if you have more than one maximal element, then it is not going to be a lattice. Similarly, in case if you have more than one minimal elements, right, then it is not going to be a lattice, because if we take these two elements, there is no greatest lower bound because there is no element below it. So in this case 2 comma 3, since there is no element below it, there is no greatest lower bound, and so we can say that this is not going to be a lattice. It is just a joint semi-lattice. Example of joint semi-lattice, example of mid semi-lattice. So these are the examples in which maximal elements are 2, minimal elements are 2, and you can even form examples in which maximal elements and minimal elements both will be more than 1. For example, if you remove 24, then the maximal element is going to be 4 comma 6. Got it? So what I mean to say is, this maximal and minimal definitions are applicable even for a poset, need not be a lattice. But if you are talking about the bounds, then it should be applicable for a lattice, right? So now I cannot say that upper bound and lower bound, because it is not unique. So upper bound and lower bound are going to be unique, and maximal and minimal need not be unique. And maximal and minimal can be applicable both for poset as well as lattices, but upper bound and lower bound are applicable only for the bounded lattice. Got it? So anyway, this particular differentiation is not very important, or important especially for the gate point of view, because no questions, I didn't see any kind of questions which are asked on the differences between these two. But in case if they ask, it is important to remember that if you have more than one maximal element, then it is not going to be a lattice. In a poset, if you have more than one maximal element, and similarly if you have more than one minimal element, it is not going to be a lattice, right? So these are the differences that you might remember, but I didn't see any questions on this in the gate perspective. But still it is better to know, we don't know what they might ask. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.